Bats are highly specialized predators. Because they are the only mammal with powered flight, and use echolocation to sense in darkness, they can fill a specific ecological niche, hunting at night to reduce competition from rival predators like birds. But because of their small size and high metabolic rate as a result of powered flight, they need a constant input of high energy from their food. Bats are crucial for many ecosystems around the world, but their species and numbers are in decline. Understanding how bats adapt their foraging strategies in changing environments is critical for forecasting their responses to future environmental changes. Researchers in Germany studied the foraging habits of the greater mouse-eared bat, which captures prey in two ways: targeting small insects in the dark sky, and scouring the ground for large insects. Because studying detailed hunting behaviors in the wild is difficult, it is unclear what factors influence the choice of hunting ground or aerial prey in bats. To fill this void, the researchers fitted 34 greater mouse-eared bats with miniaturized backpacks equipped with microphones. This allowed them to record the bat's echolocation behavior, movement patterns, GPS location, and chewing sounds, which they used to determine whether or not the hunt was successful. They noticed that the dominant foraging tactic was mostly consistent across the bats on a given night, implying that each bat adapts its strategy to environmental conditions like rain or wind. The researchers counted 3,917 prey attacks, with each bat catching an average of 25 aerial insects and 29 ground insects per night, indicating their reliance on both food sources. The bats attacked prey on the ground more frequently, with an average of 80 attacks per night versus 36 aerial attacks. Attacks on ground targets were more than twice as likely to fail, raising the question of why bats devote their limited energy to a riskier strategy. The researchers found that insects caught from the ground were between 3 to 20 times heavier than aerial prey. Because of this larger size and greater nutritional value, ground prey profitability was up to 14 times higher than aerial prey, even when accounting for the higher rate of failure. In fact, around 85% of the energy intake from a night of foraging came from ground targets, despite the similar number of aerial insects consumed. The study shows that prey switching behavior according to environmental changes plays a key role in covering the energy requirements of specialized predators like bats. Because most bats fly out shortly after sunset and return in the early morning, they are especially vulnerable to any disturbance or change in habitat quality that may reduce their foraging intake, which has concerning implications for future bat populations as human activity continues to impact the natural environment.